Chapter 12, we're going to start talking about congruence and similarity, and we're going to do this with constructions. So that word constructions for us is going to mean that straight edge and that compass. Okay, so that's where we're going to encounter these. So a few definitional things before we get started along that line. So in general, we've talked about this before, congruent objects are the same size or shape. I know this says and sometimes and works. But it doesn't mean they're in the same location. We talked about congruent versus equal, right? But the same size and shape. We also have another description called objects being similar. So two objects are similar if they have the same shape, but not necessarily the same size. And I'm going to draw you some pictures of these in a second. Congruent objects must be similar, or they are similar. Right? If it's the same size and shape, it's definitely the same shape. Right? But similar objects need not be congruent. Just because something's similar does not mean that it's congruent. We've seen the symbol for congruent before. Do you remember the symbol for congruent?
It's the equal sign with like the little squiggly line in front.
Yeah. Like that. The similar symbol is just the squiggly. No equals. Okay? All right. Who needs a compass? Who needs a straight edge?
So we need to start like bringing these.
Yes, if you have them, or you can borrow them from me if you want to. It's fine too. I'm just going to pass these around. Amy, you split that like half and half and send it to the sides. Okay, and I'll pass this back to Jacqueline for the compasses. If you need a compass, grab a compass. Okay, so while those are going around, we're going to fill in this one last slide, before we actually need the compasses, but that way you'll have them once you need them. I think they're good over there, Elena. Thank you. That's good. All right, so here's a picture of equilateral versus, I'm sorry, not equilateral. Here's a picture of similar versus congruent. All right, this picture has 4 little bitty triangles in them. Everybody see the 4 triangles? Okay, those 4 triangles are all exactly the same size and shape. They're not in the same location, so they're not equal, but they're the same size and the same shape. Okay, so these are actually, the 4 small triangles are congruent to each other. Same size and shape. But each of the small triangles is also similar to the big triangle because they're the same shape but different sizes. So imagine taking this triangle right here and blowing it up, expanding it. You take it to the copier and you tell it to enlarge it. Okay, that's what we're doing. Well, when you enlarge it, in this case they're actually doubling it, and the reason you can know that they're doubling it is because they show you that this is S and this is 2S. So they doubled every length. Okay? But in doubling every length, what it does is it keeps all the angle measures the same. And you get the larger triangle. Those triangles would be considered similar triangles. Same shape, but they're not the same size. One is larger or smaller than another one. And that's the difference between those. Okay, and everybody has a compass and a protractor, or compass and a ruler or protractor now. Okay. All right, we're going to construct a circle. So a circle is the set of all points in a plane that are the same distance, radius from a single point, the center. We've already seen this definition before in the last chapter, right? Yeah, we definitely have. So this set of videos is going to feel a little bit different. You'll notice in your notes it says construct a circle given its radius, and it says video #1, right? So I'm going to pause this video, So if you were going back to look at these, there will be separate links for all the constructions. So if you want to see how do I construct this object, there will be a link that says video 1, and you'll be able to click on that link inside of Moodle Rooms. Does everybody make sense of that okay? All right. All right, so we're going to create a list of what we did to create this circle. So do you remember the things that I had you draw just independently? I said it doesn't matter where they are or how big they are or whatever. What did we have to draw? Okay, so the first thing was we had to start with a line segment. Sometimes you're given the line segment. Sometimes you're told to create it. There should be nothing specific about the size. So like somebody asked me, what if I do it for 1 inch? And I said, that's fine, doesn't matter, right? Because it doesn't. It doesn't matter how big it is. Start with a line segment. And what else did we need? A point. Now, technically, the point could be on the line segment. It could. It could be anywhere, though, right? It doesn't matter really where the point is. So we start with the line segment and the point. Now, what did we do with our compass after we had a line segment and a point? We adjusted the compass. I like that word. Good word to use. We adjusted the compass. What was our goal when we adjusted the compass? Nice word choice. Yes, to match the length of the line segment. Okay, so now we had a compass, had the right length or width or whatever you call it. What do we do next? Yeah, and we'll call it the stationary side, right? It's the stationary part of your compass. You put the stationary point on your point that you'd created, right? So we'll call it the stationary end. So place, or yeah, I'm saying this in present tense. Place the stationary end on the point in part A, or part 1. So we'll say step 1, the point in step 1. Okay, so now you've got the stationary end on the location. What did you do next? Yeah, you turned your compass around, right? Chalk on that compass fell out. So, okay. Turn the compass. We'll just say it this way. Turn the compass around. Creating a circle. Okay, so the question is, could you do that again on your own? You're going to be expected to do all of these at some point again on your own. So that's what you want to start thinking about as you're moving your way through. Do you understand what we did well enough to repeat the process? Okay. All right. The next thing we're going to do is we're going to talk about constructing segments. So, can you think of, we're going to do number 3 here on the board in a minute, but can you think of a way that you could construct congruent segments? If I gave you a segment, what could you do to create another segment the same length? Measure it. You've probably done that before. What's another thing that you could do? I know you've done this other one before too.
Put them like on top of each other and kind of like guess.
Yeah, we could put it on top of each other. I'm not sure if you're getting quite the thing I'm thinking of. Can you describe just a little bit more?
Like you create one and then you try to do the second one like the same
you probably would have a little bit of error. There's something else we could do.
Tracing.
Tracing it, where you like put a piece of paper. That's what I thought you were saying, with putting a piece of paper on top of another one. So you could trace. Okay. We're going to use a compass and a straight edge to do it. Okay. Measuring, tracing have a little bit of error involved in them. The compass and the straight edge actually allow us to do it exactly without knowing the exact length, without having to superimpose one object on top of another one. Okay? So I'm going to pause this again, and again, if you were coming back to look at this later, that's the video 2 link that you'd be clicking on, okay? All right, so what did we start with when we were creating congruent segments? Yeah, we started with a line segment and what else? And a line. What did we do next? Yeah, we adjusted our compass to the length of the line segment. All right, so we've got our compass the right length now. Then what do we do?
Place the stationary end on the line.
Mm-hmm.
And create an arc.
Very good. We put the stationary end on the line. And create an arc. We'll see how well 4 actually writes on top of this purple. If it doesn't, I'll move some things around to see it. But the last thing basically is that the point of intersection and the stationary point this is going to have to be moved. Gives me a little more space. Point of intersection and the stationary point. Form a line segment. Congruent to the original segment.